Virtual learners, you can have out your 4-6 homework and go ahead and pause the video and correct your answers. Number 14, you guys should have gotten 22 to the 4th power. All right, so we're going to take a look at number 18 right now. And for question number 18, I have a coefficient of 9 and a coefficient of 5. So the h's are my bases. So since the h's are my bases, I can multiply 9 times 5, and 9 times 5 gives me 45. And then I'm going to take a look at my powers. So I have h to the negative 2nd power, and I have h to the 10th power. Well, if I multiply h to the negative 2nd times h to the 10th power, you add those exponents. Negative 2 plus 10 gives me h to the 8th power. So you get an 8th power. Because this has a positive power, it all stays in the numerator, so that would be your final answer for that one. You only have to move it if you have a negative. All right, what other ones you need me to do? Are you guys good on the fact that for question number 2, in order to get rid of that negative exponent, you've got to create that fraction, move it to your denominator, and then put the 1 in your numerator? Okay with that? All right, it's okay to get it wrong on the homework. Not a big deal at all. Learn from it so that way on the test or the quiz you can get that part right. All right? Yes, go ahead. Number 19, sure. So for number 19, I see that my bases are m and n, which means that this 14 and this 6 right here, those are my coefficients. So I can multiply 14 times 6, and I get 84. And then I have m to the negative 4th power times m to the negative 9th power. So since these have the same base, we're going to add. Negative 4 plus negative 9 gives me m to the negative 13th power. All right, now, this 84, does anybody know what the exponent is for the 84? It's 1. Very good. Does that have a negative exponent? No. So the 84 gets to stay in the numerator. The only thing that needs to move is this m to the negative 13th power. We're going to move that to our denominator. So that 84 remains in the numerator. And then we're going to move this negative exponent down, and it becomes a positive m to the 13th power. Any others you guys want me to go over? All right, so I believe you guys should have in your notes this example right here, correct? This is our next example. So in your notes, I want you to have this example up right here. I think you should just go back a page, and then you'll be fine. What's that? I want you to keep that for right now, okay? We're going to finish going over this first. Power is actually, go ahead and circle it. I like to circle it so I know, hey, that's the one with my negative exponent. And anything with a negative exponent has to get moved down to your denominator. So I'm drawing that fraction bar, moving that to my denominator, so that z to the 3rd power stays in my numerator. And when I move the x to the negative 3rd power down, what happens to the power? It becomes positive. So this would actually be your final answer, because those have different bases. One has a base of z, one has a base of x. We can't join those together at all. So the only thing we can do for this problem is get rid of that negative exponent. Questions on that one? All right, now let's take a look at this next one here. Do you see any negative exponents? Yeah, we do. Okay, I like to deal with my negative exponents first. Who can raise their hand and tell me what do you notice? Where is your negative exponent this time around? In this example here, where is your negative exponent located? It's different than what we've been used to. But this time, that negative exponent's in the denominator. So in order to get rid of the negative exponent in the denominator, go ahead and circle that k to the negative fifth power. If I want to get rid of that, I actually have to move it up to the numerator. So it's going to join that 9k to the fourth power. So I've got 9k to the fourth power already there. I'm going to move that k to the negative fifth up, and it becomes k to the positive fifth power. So moving a negative exponent from the denominator to the numerator does the same thing. It makes it positive. Did you write that down? Now, raise your hand if you notice something else that can be done on this problem here. Very good. So if you guys notice how on this one, I've got a base of k and a base of k. Since my base is the same, we're going to keep that 9. We're going to keep the k. And if I have 4 k's here and 5 k's here, how many do I have altogether? 9. So that becomes 9k to the 9th power for our final answer. All right. Let's take a look at this next one. Raise your hand if you see something that I can take care of here. Look at this problem. Now, these problems can be solved in many different ways. But raise your hand if you're noticing a first step. I'll give you a hint. I like to look for negative exponents first. And I like to deal with those first. Very good. Let's circle that y to the negative fifth power. So circle a y to the negative fifth power. And we're going to take that y to the negative fifth power and move it where? The denominator. Good. And what happens when we move it to the denominator? It becomes positive. So it becomes y to the fifth power. In my numerator, I still have my 3x cubed. And I still have what else? Z to the 0 power. What do you remember from yesterday? What's anything to the power of 0? 1. Very good. Nicely done, sir. So guess what? You don't even need that z to the 0 power. What's 1 times 5? 5. What's 1 times 7? What's 1 times 8? What's 1 times 12? What's 1 times 20? So anytime we multiply by 1, it just stays the same, right? So if I were to multiply 1 times 3x cubed, it would just be 3x cubed. Do I have any negatives to deal with? No. And we're done. That's your final answer. We rewrote it with positive exponents. And then I've got an x as a base and a y as a base, so I can't join those together. Do me a favor. Put your pointer finger up. Test in the wind, except you can't lick your finger because COVID. Test in the wind. And use the pointer finger to cover up those x squared and the x to the fifth. I just want to look at the 12 and the 15. What can we simplify the 12 and the 15 by? What can both 12 and 15 get divided by? 3, right? So go ahead and write divide by 3 out here. We're going to go ahead and divide both our numerator and our denominator by 3. What's 12 divided by 3? 4. What's 15 divided by 3? 5. And then now I'm going to write my x squared and my x to the fifth power. Because I haven't dealt with those x's yet, I'm only simplifying that fraction. Now, test the wind again. Hold your pointer finger up. You guys ever done that? And you're like, check it, testing the wind. And this time, cover up the 4 and the 5. And I see x squared and I see x to the fifth power. Do they have the same base? I have 2 x's in my numerator. And how many do I have in my denominator? 5. So do I have more in the numerator or denominator? Denominator. So I'm going to write the 4 and the 5 that I had at the beginning. Those are still there. And you guys just told me that I have more x's in my denominator, correct? So all my x's are going to end up in the denominator, so I'm going to write them there. And how many? 3. Very good. Watch this. If we had x squared, there would be 2 in the numerator. If we had x to the 5th, there would be 5. Cancel. Cancel. Remember doing that? When they would cancel? So do you see how there are 3 more x's in the denominator? So we have x to the 3rd power in the denominator. Does that make sense? Okay, go ahead. Which one? This one right here? Yeah, because it's x and y. They're different bases. Yep, you can only cancel if you have the same base. Does that make sense? All right, let's take a look at this last one. Raise your hand if you see something that you think we can do right off the get-go. Anything. There are a couple different first steps that we could have here. Okay. What do you guys think we need to do first here? What do you think we should do first? Very good. What you would like to do is take these t's, and I'm going to only take the t. The 12 and the 5 get to stay in the numerator. So I'm going to keep the 12 and the 5 in the numerator. The 12 and the 5 stay. The base is just t, and it's just t. So I'm going to take those negative exponents, and I'm going to move that t to the 7th power to my denominator, and I'm going to move that t to the 5th power to my denominator. So the 12 and the 5 get to stay because those are my coefficients. They're not my base. My base is t, so the t's have to move. Did you guys write that down? Did you write it? Now what do you see could be done? What do you think? Very good. Times the numerators. What's 12 times 5? 60. Good. And then I love that you said add in your denominator. We're going to keep the t. And what's 7 plus 5? What's 7 plus 5? Just tell me. 12. All right. I want you guys to flip to your 4-6 worksheet. And we're actually going to flip to the back of it. And for homework tonight, you guys are doing 23, 24, 25, 26, 27, 28.